horizontal tangent.
Oh my God, Mr. Boyd! You were a bald baby, weren't you?
Yeah.
That's most babies, Jordan.
That's the best you can do, bald too?
No, because you're bald.
Yes, I am. Oh my gosh. All right.
Can you not see the picture over there? He had a full head of
Okay.
hair a couple years ago.
So,
No.
he's so cute. Oh, that's not all I've got.
Oh,
I
he's
just
got.
didn't decide to pull it all out. So, anyway. Okay. Now, all right. Seriously. There is a hierarchy of the divergence and convergence tests. And I had been mentioning that the divergence test is the one you always need to think about. So I want to show you you can kind of see how this flowchart works. The first thing you want to do is test for divergence. Does this limit to infinity equal 0? If the answer is no, there's your answer. Series divergence. If the answer is yes, then the next thing you need to consider is it a p-series? Got it? If the answer is yes, then you look to see if p is greater than 1. Got it? If the answer is no, then you would consider geometric. And see how it works like that? All the way down. Now, telescoping series, don't mark it out, but you are not required to know it. That is not AP tested. Okay? And a couple of these, Taylor series, okay? Taylor series is taught next week. We did direct comparison tests and limit comparison tests, and of course integral tests. Ratio and root tests, those are tomorrow. Okay? Ratio and root tests are really tomorrow on Monday. I think we can do both in one day, and then we can use Monday as a chance to, I'll give you some more and more examples, and what you can do is you can apply the flowchart. Okay? All right? And then of course alternating series, and that's what we were talking about yesterday. And I will update our cold sheet today, because there's 2 alternating series parts to put on. So we'll add those in. I think we need to go back to this for just a second. That is just so look at even magic.
Where did you even get that?
I don't know.
I bet $1 that he got it from Luke's yearbooks.
And you know what?
Your son.
Doesn't look any different. That could be.
I'd like to
I can
think
put
I
that.
have.
Huh?
I'd like to think I have.
But I don't.
It's the same.
It's. All right. So I'll show you mine someday. They're awful. The one year I gave myself a haircut.
Oh, dear.
Didn't work. Okay.
I was thinking this would be.
All right. Where's my little script here? Okay. So yesterday we looked at. Did we finish alternating series? Yes, we did the last example. So make sure there's no substitute for the homework on that one. Yes. So I'm going to turn the page and we're going to talk about something else. Excuse me. It is something called the alternating series remainder. The alternating series remainder. Okay? All right. Now, there's a verbal setup to this that has to be worked out to be understood. Okay? If a convergent alternating series satisfies the condition, the n plus 1th term is always less than or equal to the nth term. Okay? Then the absolute value of the remainder, I'll explain what that means. We're going to call that capital R sub n. Okay? The absolute value of the remainder, capital R sub n, involved in approximating the sum, capital S. Now we're approximating the sum, capital S, by something called S sub n. Of course, this makes absolutely no sense what I'm talking about. Please understand that. Okay? It will in a minute. All right? Is less, so I'm talking about the remainder. All right? So the remainder involved in approximating the sum S, the actual sum S by some S sub n, is less than or equal to the first neglected term. Okay. That makes absolutely no sense. And I'm going to give an equation that also doesn't make any sense yet until we apply it. Then I think it'll make perfect sense. The equation would look like this. Absolute value, capital S, minus capital S sub n. Okay? So I'm taking the absolute value of that difference. Okay? That is equal to the remainder, absolute value of the remainder. My claim is that that has to be less than or equal to A sub n plus 1. Okay. Now, some of that's going to go on your cold sheet. The rest, we'll whittle down those 5 lines into something more sensible. Okay. So, let me explain this to you, and then I'll show you an example. An alternating series, if it converges, in fact, anything that converges has a sum. Okay? Because if it didn't converge, it would diverge to infinity. The sum would add up to infinity. Now, we don't often, except with geometric series, we don't often actually sum them up. Now, I could with a geometric series. I could with an integral test, because I get, if it converges, I get an answer. With p-series, we don't often get asked to add those up, but with an alternating series, we might. We might be asked to sum, or at least approximate, the sum of an alternating series. And all this says is this. There's no formula, okay? Integral test, I integrate, fundamental theorem. Geometric series, there's a formula for that. But there's no formula for an alternating series sum. But we can approximate very, very closely. And what we do is this. We take the sum, we add up the first X number of terms, say the first 5 terms. Let's add up the first 5 terms of a decreasing series. Because if it converges, the terms have to be decreasing. Got it? Now, what do I know about the first 5 terms of any decreasing series?
Each one will be smaller.
Right? They are the largest ones, yes. Okay? They are the largest terms. The first 5 terms are going to be the largest terms. Okay? So, I could actually approximate the sum by just adding up the first, say, 5 terms. Right? Because what do I know about terms 6 through infinity? They're going to be incredibly small. And if the series converges to a number, then they may be so small as to almost be what we would call negligible. They don't add up to much. Okay? Like my children. They don't add up to much. Okay? So, that's a joke. You still mad? I'm not talking to you. I could have gotten it from your dad. How do you know?
You were talking about it the other day.
Betrayal. We have no contract here. Okay, so the remainder that's that difference. The actual sum, which we do not know, minus the sum of a finite number of terms, a small number of terms, because I still have to do the math there. That's going to be my remainder. And the thing is here, that remainder has to be less than or equal to, in this case, the 6th term. The first neglected term, the one I didn't choose. So if I say add up the first 5 terms, the first neglected term would be the 6th term. That remainder has to be, or will be, less than or equal to the 6th, or the n plus 1th term.